y equals ax to the power n, sort of an exponential function which sort of exists, right? Is naturally existing in terms of everyday life, so population growth, financial markets, and so on. Okay. Now we could have data, and it's often good with data, okay, to have it plotted in terms of logarithmic axes, okay. And then if we have sort of linear relationship here, okay, which sort of would exist in the example we've got here, then we can actually work out what the exponential function is in terms of the growth or whatever, okay, using the values given on this linear relationship. Now, to understand why that works mathematically, what we can do is start off with this here, right, and take logs of both sides, okay. So we've got log of y equals then to log of ax to the power n. So I'm taking log of both sides. Now, in this case, okay, the base is 10, yeah, okay, because there's no base written, so we'd have that there. We've got log of y equals log axn. What I'll do then is I'm going to split up, I'm going to separate these logs here. Now, because we obviously multiplying these here, we can write them as two separate logs, okay, where we're adding the logs using laws of logarithms. The next thing we can do then is, okay, is bring that power down, the n down in front of it. So we end up having that there, okay. Now what I'd like us to do then is to perhaps rewrite this. So we've got log y, just swap these around, right? So we'll have n log x plus log a, okay. So just swap them around. And then, right, the idea we've got here is we've got x and y axes, but capital Y, yeah, capital X, okay, because the axis is actually a logarithmic axis in terms of log x, and this is a logarithmic axis in terms of log y, okay. So essentially, my log y values here, okay, essentially become my y values, okay, along this axis here. The same then with the log x values become my x value axis along the axis here. And I get this, okay. Now you'll notice this then is very similar to what we know as y equals mx plus c, okay. It's got that sort of relationship, so you can see there in that format they want. So y equals nx plus c, okay. So with y equals mx plus c, or in this case y equals nx plus c, of course that would represent the gradient, okay, and that would represent the y-intercept, okay. But we know, okay, that the c, quite simply, is also the value of log a there. Okay, so if we look at our graph where it intercepts the y-axis, it intercepts where y is equal to 2, okay. Okay, so the c, in this case, is equal to 2, but we know the c, constant c is actually log a. Okay, so if I've got log a equals to 2, I can then work out what a is equal to. So I've got log to the base 10 of a equals 2. So to get a, I take the base over, swing the base over, so be then the base to the power. So I get a equals 10 squared, which is 100. So straight away there I've worked out what a is, and that's the objective, isn't it? I want to work out what a is. Okay, I also need to now work out what n is. Okay, in terms of working out what n is, n sort of follows the format y equals mx plus c. N would be the gradient, wasn't it? So to get the gradient, okay, quite simply, I would do y2 minus y1 over x2 minus x1. So we've got, if we look at this here, well, my y2 is 8 and my y1 is 2. So 8 take away 2. And then my x2 is 9, my x1 is 0. So 9 take away 0. So if I work that out there, I'll get 6 on the top, 9 on the bottom, so that's 2/3. So remember then, the format is y equals ax to the power n. So then my a is 100, x then to the power n, and my n is 2/3. So we're done. We've got y equals 100x to the power 2/3.